Thank you very much.
Got it.
I guess this is the mic we can use.
Yeah.
Well, it's always a privilege for me to come to Andalusia. You can see I already use the local uniform, all in green, because that's close to my heart. When I think about Andalusia and research, I think about a big discoverer, Christopher Columbus. He sailed away from Cadiz. One of his graves is here in Sevilla in the cathedral. We say Columbus was also the first socialist because he asked for money from the Spanish kings. He didn't know where he was going. He arrived somewhere. He had no idea where he was. He came back. He didn't have a clue where he had been. And all that with government money. Well, we in the private company have to be a little bit more focused on what we do with the resources we have. And that's what I wanted to transmit to you today. How do we build an agenda? How do we decide where the money goes? Of course, as a company, you have an owner. That is always an important decision maker. In our case, Aqualia, a small water company, is part of a large FCC group that had close to 100,000 people. It was based on construction, so the last few years have been a little difficult, but it's also based on infrastructure operation. And therefore, we do, of course, build railways and build highways and operate airports and other things that maintain us, not only in Spain, but also worldwide. And you can see here that the international activity is now more than 50% of the FCC turnover. And of course, Aqualia, as the provider of water services, is, in our view, the heart of the business. And that's what I want to show you a little bit, this variety of activities that the water company has and out of which it has to crystallize the research priorities. We serve more than 1,000 clients, more than 1,000 different municipalities. In Spain, each mayor has the freedom to decide how he operates his services, whether he has his own public infrastructure or whether he actually trusts an operator. And therefore, we have operations all over the country and also in other neighboring countries, in Portugal, in Italy, in the Czech Republic. But we also do large international design build projects, whether it's a wastewater treatment plant in Egypt or a drinking water treatment plant in Montenegro or a desalination plant in Algeria. That often goes with a concession of 25 years operation. So we build, design, operate for a long time and have to finance all that. And therefore, we also need financial engineering as part of our activity. In Spain, we cover about 30% of the market, and therefore, of course, we think we are the #1 Spanish company in the water business, even though we also work in 17 other countries as far as water and wastewater services. For instance, wastewater collection systems in Abu Dhabi or drinking water distribution systems in Riyadh, or of course desalination in Chile. All that is part of our interest. Even though we're still a modest company compared to the other large water companies, there's 2 French giants that dominate this sector. They are both 5 times bigger than Aqualia, but among the rest of the field, we are leading. You can see there's about 5 Chinese companies here in the top 15 water companies of the world. Obviously, those will grow rather fast and probably be our fiercest competitors in the years to come. But there's also other European companies, German and British, not only French. All these companies, of course, invest in research, even though water is a very conservative activity. It's not computer science. Therefore, you will see that most of the percentages are rather modest, between 0.5 to 1%. The leading company in France is devoting 1% of its turnover to research and innovation. In Spain, a public company of Madrid and the company of Barcelona are the leading ones. They are close to 1% nowadays. Aqualia is still behind. We focus more on operations because we have a decentralized operation, not like Madrid or Barcelona, where you have a lot of massive population and therefore a lot of resources concentrated. We serve many smaller and middle medium-sized towns such as San Sebastián or Vigo or Almeria or Avila, always 200,000, 300,000 people, because that is the economical factor. At that scale, it makes sense for the mayor to trust a private operator. But you can see we have many, many playing fields. We operate 200 different drinking water plants, 300 different wastewater treatment plants. All that, of course, will drive our research agenda, the needs of these plants and the needs of our clients. Although we do, of course, put some big objectives on the top of our agenda. We want to improve quality of our services, quality of the water we distribute. We want to improve sustainability. We heard it before, do more with less, have less emissions, less energy consumption, and of course be a good operator, meaning have very efficient management tools. Hopefully we can send you a bill before you even open the tap to draw water. That is obviously our dream, to be efficient and serve our communities in a sustainable manner, providing the quality that the European community requires through the various directives. Now, we are also driven by our creativity. We have 7,000 employees. Those are 7,000 creators, 7,000 innovators, 7,000 investigators that can contribute to the research effort, even though I do lead a group of about 20 people that centralize some of the research administration. The activities of research is always done in the local plants, in the 200 drinking water plants, in the 300 wastewater treatment plants. Therefore, the management of this creativity and the management of this project is very important. And we do have working groups that coordinate this effort. And all that is organized by an instrument that is very common in Spain, the UNE, the Spanish standard 166002, that guides how you create research, how you manage research, how you then harvest the results, and how you organize all the documents. And that's of course important. If you have 7,000 people participating, it all has to be organized. And many other companies in our sector use that same instrument. Water companies like the one of Sevilla, Emasesa, and others regional, and also the engineering companies and providers of services to us have similar methodologies, so we all know how the system works. Aqualia's activity as far as R&D is still very modest. I started my job almost 5 years ago, and that time we were a little bit over 1.5 million euros as far as research investment. Obviously 2008 was a bad year to start new R&D. As soon as I started my job, the emails came coming in, cut cost, no more initiative, no more investment. So we managed to maintain our activity nevertheless. And you can see then, when the worst was over, we grew very, very fast. We are now double the activity that we had 4 or 5 years ago. And of course, all that has been thanks to support that we got from various agencies. In Spain, you have a number of wonderful instruments, from the local governments to the national government, and of course all the way to European agencies that support research. So nowadays we are about 3 million. That's is enough for many people that we can activate in our organization, even though as a general number is still modest, less than 0.4% of the turnover, but 5% of the profits, so it's not negligible as a number. So what do we do with this money? I will show you a few practical examples on where we invest. This first investment is on biosolids handling. You know that the biggest problem of wastewater treatment is that something is left over and nobody knows what to do with it. And as more and more guidelines ask for more and more treatment, more and more sludge accumulates. So we invested in one activity, how to deal with sludge better, make energy out of it, make a good final product for agriculture, disinfected and easy to use. That was the idea here of the thermal hydrolysis process we tested with a small company of Norway in Salamanca. And I'm very happy that Manolo Garcia Roig, for instance, here from the University of Salamanca, who also helped us to implement this project, because we never work alone. We always work with local support, with local universities. And in this case, this project is now over, just finished last year at the end, has a patent going. The main idea is to destroy sludge in a more efficient manner by cooking it with a pressure cooker, 165 degrees, 6 bars, and all the biomass becomes very, very accessible for the bacteria. And what before you did in 20, 25 days of digestion, you now do in 10 days, so you reduce by half the necessary infrastructure, and in addition you produce more biogas, and in addition you have a final product that is disinfected and easy to dewater and easy for the farmer to use. So that is an important aspect for us, of course, to make sure that all the final residuals are efficiently used. But we also have very, very different day-to-day preoccupations. For instance, this is a very modest project that one of our operators came up with, just saying, well, I need a way to guide my maintenance. I can't just change my pumps and my centrifuges whenever I want, and I can't wait for them to break. So I need a tool to monitor those equipment, and therefore he formed a consortium. He found money at the Ministry of Education to give us methodologies to predict the failure of instruments, cameras and sensors, and together with a few other partners we managed to implement this project and have now done 6 different training sessions to have a task force that can go from plant to plant and analyze the status of the equipment and therefore prevent failures and prevent problems in the service. We have some other challenges that come from legislation. Suddenly the Ministry of Health in Spain decided no more acrylamide in drinking water treatment, knowing that this polymer had a critical function in coagulating and separating pollution from drinking water. So we had to come up with a quick solution to replace this chemical. And again, we teamed up with chemical suppliers, we teamed up with some of the other water companies because it's a problem that is common among the industry. And this was all with our own funds from the suppliers, from the water companies to provide a solution. And we now have found some other products that can replace at least partially this polymer. And there is, of course, always the objective of having better water quality, having more efficient reactors. One of the key technologies in the last 10 years was the Membrane Bioreactor. It's a reactor that allows a very compact treatment and a very high quality treatment, because with membranes you have water that is ready for reuse. The only problem of this technology was that it was very, very energy intensive and used about 3 or 4 times more energy than the conventional systems, and that was one of the objectives here, to try to bring this process in line with more sustainable energy levels. Again, working with suppliers of technologies, and we providing the platform in our treatment plant, this time in Vigo, to improve this technology. That also is now finished, and we have an alternative now with different membranes that clean themselves with plastic carriers and have a more optimized operation that we can use in the various reuse plants that we operate. Another very interesting technology we got from the Netherlands. There was a professor in Delft who had this idea about Anamox, a new pathway how to eliminate nitrogen in a more efficient way. With a new bacteria that instead of going the traditional nitrogen cycle, using lots of oxygen, therefore lots of energy to transform ammonia into nitrate, then using more carbon, more energy to retransform the nitrate into nitrogen. There's a bacteria that can do that in a shortcut and using less energy and producing less sludge and less carbon. And that one now we have already on the next scale. This was the pilot phase, 2 years of pilot phase. You can see this red bacteria here. Those are the specialized Anamox bacteria that allow to oxidize ammonia in an efficient way. And now we're already implementing it on large scale in some of our treatment plants, because they all have to meet the nutrient removal guidelines, and therefore we avoid some energy consumption and some sludge production thanks to this Anamox process. And there are similar ideas, always trying to reuse more water in a more efficient way, not only with aerobic MBRs, but also with anaerobic membrane bioreactors. Anaerobic means you can actually harvest methane, harvest energy out of the water, not put in lots of oxygen and lots of energy to destroy pollution, but harvest that pollution to produce energy and at the same time have a reusable quality water. This is what we're trying here with this anaerobic MBR for industrial applications with a ceramic membrane. Again, using, of course, partners in Madrid, in the Basque Country, implementing the pilot in a specific location in Valencia, where it can already be used for the next upscaling. And we have finished this pilot phase, and we're now in the prototype phase where we show a big potato manufacturer how he can use this process to harvest energy out of his wastewater and at the same time meet the reuse standards for the local industry. Those were some small examples where you can see how we try to improve quality, how we try to harvest our resources in order to give a better service. But we were also privileged enough to participate in very large consortia, FP7, and also the big Spanish research consortia. There was a CENIT program, now there's an Impronta program. In each one we were fortunate enough to have a consortia that won. It's a big effort to consolidate these big groups, often 10, 15 companies, and you know how hard it is to have people that are competing potentially focus on a joint project, but we managed in these various projects to come up with an attractive menu where everybody found a way they can contribute in a productive way. And you can see the budgets are somewhere between 10 and 20 million. That looks like a lot, but if you divide it by 15 companies and divide it by 4 or 5 years for each company, it's actually not that much for each research priority. One example is what we call ICIS. It's the research about a sustainable island. And the idea is, as we are a group company that generates infrastructure, we want, of course, sustainable infrastructure. A lot of infrastructure we have is inherited over the centuries and might not be the most sustainable ways. The whole water cycle is a little absurd if you see that cities pump water from 100 kilometers away just to flush their toilets, and in the meantime treat it to a very, very high level and don't use the resources in the wastewater. On the contrary, put in more energy to clean it up. Maybe there is a way to rethink the infrastructure, and that is the idea of this Sustainable Island project, where we work within the FCC group with our construction partners, with our energy partners, with our waste recycle partners to rethink how would the urbanization of the future look like. And of course you can, for instance, harvest water of various quality, gray water, yellow water, black water. All that could be used in different ways, and you could recycle part of it, transform part of it in energy, using, for instance, organic matter from solid waste as well. And of course, this is also a 5-year project where we look at all these different pathways. Under what conditions does it make sense to rethink the infrastructure? Similar efforts are known under the code word ecological sanitation in Switzerland, in Sweden, in Germany. And of course, we're trying to get the best ideas and sort them out and decide in which condition do they work. And each geography is, of course, different. But our dream is, of course, to have small entities within an urban framework that are more or less self-sufficient as far as energy and other water and wastewater services. And the last big project I wanted to present is our dream to convert wastewater to biofuel. And we have a wonderful FP7 project going that is called All Gas. And the idea is to use wastewater to grow algae, and algae to harvest energy, because algae have potentially some oil in it. At least you can digest them with anaerobic digestion to biomethane, as we always do. Every big wastewater treatment plant is a bioenergy factory. Every big wastewater treatment plant, at least 50% of its energy it produces by its own digestion of the solids. But in the end, what we use today in wastewater treatment is still a rudimentary process that was invented 100 years ago in 1914 in Manchester, in northern England. Not every idea that has been invented in northern England is applicable in southern Spain. So maybe there is ways we can improve it, and this is rethinking the wastewater cycle, trying to harvest energy and nutrients instead of destroying them, because the traditional way is get rid of ammonia, get rid of phosphorus, even though it costs you a lot of energy. We want to avoid the energy use. On the contrary, we want to produce energy from nutrients and have a positive energy balance in the wastewater treatment plant, with algae cultivation as the main biological process within that biorefinery, because then once you have the algae, you can extract various potential valuable products, colorants, proteins, and at the end you always have some residual that could be made to methane. And those of you who are from Italy know that there's 500,000 taxis that work on methane. All the big bus fleets in Spain work on methane, in Barcelona, in Madrid, in Sevilla. And 1,000 trucks within our company work on methane as well for garbage collection. So it is a sustainable fuel, and if we can gain it from wastewater, it will be more sustainable yet. So this is a long project, of course, FP7, 5-year project, with many partners that help us in the various aspects of the cycle. Here you can see where we implemented in Chiclana, about an hour from here south, as far south as you can go in Spain. Little wastewater treatment plant that you can see, and 10 hectares next to it, where the community, the European community said, build a 10-hectare algae farm to show that this is a realistic process. And we start, of course, step by step. You can see the first algae ponds that we build, and we hope that in 5 years we can show you the 10 hectares operating. And you can also see our research center there that we built on the site of the El Torno wastewater treatment plant. And with that, I think I finished to give you a little bit of the panorama of the various points that are on our agenda, and how within a company many forces from outside and inside build this agenda that we implement. And we hope that in 5 years we will have less skeptical faces than Prince Charles and Prince Philip when they look at algae culture and already think biofuel. Thank you very much.